Hello and welcome to the directions video for the Calorimetry Lab. In this lab we're going to do some heating and cooling experiments. Here I have boiling hot water that I'm going to use to measure some temperature changes. That's going to be my T-hot as referred to in the lab. Alright, over here I have my calorimeter, which is just a small teacup. You can use a styrofoam cup, that works very well, but a teacup works especially if you wrap it in towels like this so it's insulated, including a towel below it so it's not losing heat to the table below. Alright, so I also made a lid for it out of cardboard. This is just to help with some of the convection heat that would be coming off the top. And there's a hole. The good thing about having a shallow teacup like this, or maybe a styrofoam cup that is cut down a bit, is that you can have the thermometer really reach the bottom, because you don't want a lot of water and you don't want this to not be able to reach the bottom, the actual tip of your temperature gauge, okay? Your thermometer. Alright, so the first thing we're going to do is just test out what's the temperature change from the system itself, which is the calorimeter. So how much heat is it going to consume? How much heat is the metal tip on the thermometer going to consume? And to do that, we simply take some hot water that we're going to scoop up. All right, and we're going to measure this water after the fact. Okay, and then we're going to go ahead and put it in. So the water was at 100 degrees. Okay, we're going to pour it in, and we can weigh that water by pouring it out after we're done. But what I do now is put my lid on and take a temperature reading. And based on that temperature change, I can find out what's the equivalent mass of water that my cup and thermometer is consuming by reaching equilibrium with the water, okay? And so you see here my temperature gauge is in Fahrenheit, which means I have to do my readings in Fahrenheit and then transfer it over to Celsius. This is less of a glare. So you see it's 170, 174, and we can let it reach equilibrium, okay? For the purpose of the video, we'll say, okay, well, I'm not gonna be that careful, and I'm just going to have it reach equilibrium. One thing is if you wait too long to reach equilibrium, you're just going to see it gradually cool. So you got to hit that point before it's just gradually cooling with the environment. Okay, so we can probably say that maybe 174 was a good number, and that would be in comparison to the temperature of the water, which is about 214 degrees. That's again in Fahrenheit. Converted over to Celsius is 100. Okay, all right, give or take a degree, right? Just the inaccuracy of the thermometer. Okay, so that's the first procedure where you're finding the mass equivalent of the actual cup and thermometer. All right, so now we need to put in our metal sample, okay? My assistant here is gonna put the metal in the boiling hot water. And put all the nails in the boiling hot water. Take all these nails and put them in the boiling hot water. Just throw them all in there. Okay, all right, not those ones. Okay, so here I have one set of nails. I'm not including the other ones because they were not the same type of nail. So maybe they're made out of something different and they didn't fit as well in my cup. All right, and so you want to leave these in here for a few minutes to let them definitely reach equilibrium with the boiling hot water. It can take a few minutes, especially for some materials, to really have that temperature equilibrium throughout, depending on its density, of course, and just how big it is. So, and we just want to be on the safe side. But here, for the purpose of the lab video, we'll say, hey, they're at equilibrium. But for you, you should really wait 3 to 5 minutes to make sure they're really at equilibrium, okay? Now, one thing I want to do is I want to remove this hot water and get some cool water. Can you get me some cool water, please, assistant? Dump out the hot water and get cool water. Okay, and this would be a known quantity of water. You'd be getting it at room temperature or faucet temperature. You want, and I'm going to take the temperature reading of that water right before I do it, and then see how much it heats up when I put in the nails. And one key thing is here is you just want a little bit of water. You want to kind of gauge just enough water to cover up the nails. No ice, please.
Okay, I'm putting ice in the scoop. I always have ice in the scoop, so just it's in there.
And the reason we don't want ice is because then we'd have to really know exactly the mass of the ice and think about the phase change due to actually heating up the ice. Okay, so let's see. I'm gonna make it so just a little bit of water, right? Because I only want a little. Because the smaller amount of water that you use, the easier it is that you're gonna actually get a nice measurable temperature change. Because water has such a high specific heat that if you use too much, then you're gonna get a really small change, and that's gonna be pushing up against kind of the error margin of your thermometer. Your very affordable kitchen digital thermometer. And the one that I recommended does measure in Celsius. I'm just using the one I already had around, not the one that was class recommended. Okay? But again, doing conversions from Fahrenheit is not a big deal. Just take all your readings throughout the experiment. Okay? All right, so now I want to actually go ahead and get my nails. Before I do that, I'll not forget to take a temperature reading of the water ahead of time. Okay, so let's see. Okay, so we have, we'll say 76, 76.2, 76.4. So I guess we'd say 76.3 is our current temperature of the water. Okay, now you want a good way of like grabbing these fairly quickly. Obviously, filming the video simultaneously. I'm doing the best I can. All right, and that's good enough. And we'd use that as our mass. We measured it after the fact. I'm gonna cover it up. It does take a little bit to reach equilibrium. It still should be warming up at first. Stir it around. All right, and then we'll take our temperature reading. And look what we got, 84.2. Okay, and then you could be really sure that it's really at equilibrium. Move things around a bit, see if it starts to fall, because then you know that you've maxed out. Okay, but yeah, it looks like 84.2. All right, so we have a really nicely defined temperature difference between what the water was before we put the hot metal in, and then what the temperature with the metal was after the fact. And then since we know the mass of the water, which we can easily weigh by just taking the difference of the full cup with an empty cup, and we can obviously put the nails right on the scale, we have all of our known masses. And there you can calculate the specific heat of that metal, whatever metal that nail is made out of. And of course that's based on the fact that we know the specific heat of water. It's a well-known constant at 4,186 joules per kilogram degree Kelvin or degree Celsius, or 1 calorie per degree Celsius per gram. Okay? All right, or 1 kilocalorie per kilogram. All right, well there you have it. Those are the directions for the Calorimetry Lab. I hope it's been informative and it looks like kind of a fun lab to do at home. All right, well thank you so much for watching.